Welcome to Math 106, Chapter 4.6, where we're talking about properties of natural logs and then using that idea of these properties in order to help us with a shortcut uh, to differentiating, so to deriving. So first up, let's just get a warm up by simplifying the following with your properties of logs. So first off, what we're going to do is make sure that all of your subtraction signs are going to be on the latter half, right? Because we talked about, hey, what we can do to make it a little bit easier to see. If you have two subtraction signs, right, what we can do for starters, and you don't have to do this right away, but we can always say, okay, well, let's go ahead and factor out that negative. And you don't have to take this approach if you don't want to. And we talked about, hey, if there is anything being subtracted, that ends up in your denominator. Instead of having multiple division signs and then trying to figure out how to simplify that, just take out the negative and then change it from there. So now that negative is on the outside, we can also recall what to do with numbers that are located right in front of your ln. So we can put those up top. So we have ln of x plus ln of 4 plus ln of y cubed minus ln of x squared plus ln of 8. So now we can go ahead and work on, okay, these are particular signs. So we have a plus sign, a plus sign, a plus sign, and then a division sign. So any plus sign, we can go ahead and say the plus signs are going to turn into multiplication symbols. So we have 4 times x times y. That subtraction sign is going to turn into division between the multiplication of x squared and 8. So we have 8 and x squared. Now we only want to make one ln. So once we have everything together, we can make one ln and put this all together. And now it's up to us to simplify, right? 4 and 8 can simplify, so that'll go to 2. We also have bottom heavy x, so we're going to leave one x behind. So you have ln of y over 2x. And that is your simplified form, right? So understanding, and actually this is y cubed, forgot my cubed here. Now, this is the understanding of your property. If you can go from that expanded form into a condensed form, then understanding that from the condensed form, we can also go ahead and break it apart. So now let's work on those properties down below and see if you can fill in the blanks and correctly identify how to break them apart. So here you have your property of your product property, where it says that if you have some sort of multiplication symbol, right? And it could be the implied multiplication, right? Not always do you see that symbol, but we can break it up and make it addition. That is the addition between some sort of x and y. And we're going to break it up with multiple ln's. And you can see that over here. You can break 6 up into 6 times 3. You could also break it up into 1 plus 6, right? And then 1, we have to recall what that property is, right? Or 27 can be broken up as 3 times 9. And you can break it up in lots of different factors. Now this one, right, is that that division sign, right, your inverse or your quotient rule, if you want to say that as well, is that if you have some sort of division, that is going to turn into some sort of multiplication, or sorry, well, some sort of subtraction. Whereas we have this ln of 1 up top, and your ln of x is doing the subtraction. It's doing the dividing. So this one gets to come down over here. Now we do have to recall what the ln of 1 is equal to. So we can just put a little question mark. We have a base of e always. So it just says e to the what power is equal to 1. Therefore, that needs to be a 0. E to the 0 is equal to 1, and that checks out. So this is equal to 0. Therefore, if you have ln of 1 over x, that is just equal to negative ln of x. Same thing over here, any sort of 1 over 1 over, you'll end up with just your bottom variation. Now, your quotient rule is very similar to that. It's just meaning that, hey, there's not not so much of an inverse property. Instead, right, what's doing the subtraction is doing the division. And we have multiple ln's here. So that division turns into subtraction. We also have the power rule, where the power rule, we just bring down your b here and multiply it. So we have b times ln of x. And you see that here. Instead of doing this out as an 8, you can, in fact, put it in front over here. Same thing in front over here or in front over here. So based on those rules, we want to feel confident in those, because if I'm asking you to differentiate this particular one, notice that there is an ln here already, right? So you'll notice that, hey, we're going to have to, what it looks like is take the chain rule and then do the product rule. But the product rule, right, the one that we know only contains those two functions. So the product rule, we would have to expand it and go a lot more in depth. So instead, right, take what we know about the properties of ln, right? There's multiplication in between these two. And as we saw, that multiplication will turn into addition. So we can add between these two. Break them up into the ln of x plus the ln of x plus 1 plus the ln of x plus 2. All of those little multiplication symbols here will turn into the addition based on your properties. And again, you have your ln, all of them have some sort of ln. So this is kind of creating a shortcut. So step 1 is to break them up. And then step 2 is then to go ahead and differentiate. And this one is nice because you can take them in chunks. Think about how you derive x to the 4th plus 3x squared plus x plus 1, right? Well, you're going to do the derivative of this one plus the derivative of 3x squared plus the derivative of this plus the derivative of this one, right? So you can take it in chunks. Same thing, you get to derive in chunks. So you could say, okay, this is the derivative of now ln of x plus 1, and one more time, the derivative of ln of x plus 2. So see if you can pause the video here and now go ahead and derive these in chunks. So here, right, we have just plain old ln, which we now know that it is just the ln, or just 1 over x plus, and then we have 1 over x plus 1. And keep in mind, you do have the chain rule of that ln of x. Same thing, chain rule here. The chain rule doesn't matter so much for this one because each one just has the derivative of itself. Plus 1 over x plus 2, chain rule it, times 1. So this is the derivative of this whole thing. So it helps us avoid the chain rule, or sorry, it helps us avoid the chain rule and then having to do the product rule with 3 separate derivatives along with the other counterpart. So your final answer is this. Let's have you do one more, and I'll just do a really quick one over here. Let's do y is equal to ln of x to the 4th times 2x plus 3 and x plus 1 cubed. So see if you can pause the video and try that one out. So step 1 is converting these into separate logarithms. Okay, so that is just it written out. Oops. And now we can go ahead and derive with deriving these separately. Okay, so now let's go ahead and derive. Now, if you want to, you could always do some other property where you can put the 4 out in front right here. And I might even show you that over here. If you wanted to do 4 ln of x plus ln of 2x plus 3 plus 3 ln of x plus 1. And then you can go ahead and then derive these in chunks. It's not really going to matter much. So here we have 1 over x to the 4th. And chain rule, right, we have 4x cubed here plus 1 over ln, 1 over 2x plus 3, chain rule of just 2, plus 1 over x plus 1 cubed. Chain rule, we now have 3x plus 1 squared times just 1 itself. And that 1 is just the derivative of that 1. So all together, we have 4x cubed over x to the 4th plus 2 over 2x plus 3 plus 3x plus 1 squared over x plus 3 cubed. And I told you, hey, it doesn't really matter, right, if you were to do this rule over this rule, but just know that when you go ahead and do this rule, right, we have 4 times 1 over x. So this becomes 4 over x. So how does 4 over x, right, if we have 4x cubed over x to the 4th, right, if we know that this is supposedly the same thing, notice that when you simplify, this becomes 4 over x, just like if you were to extend some of those property knowledges, right? The other one, we don't get to simplify much. No, those 2's don't cancel like that. Now, if we were to simplify it one more time, notice that we're canceling kind of 1 for 1. You have 1 left over. So that means if we were to derive this one, right, this is 3 times 1 over x plus 1. So it makes 3 over x plus 1. That is exactly what we have here. You're just getting there in 2 separate ways. One way is to use the extended property. So these ones, this one and this one, you just use that property a little bit further. Whereas this one, right, if you were to continue downwards, you just do the chain rule in itself, and then you have to simplify. So it's completely up to you on how you manage those. So this is if you have an ln with that shortcut. Now we're going to see a variation of what we can do if we don't have an ln. So such as this one. Right? In which case, it looks like initially, oh my goodness, we are going to have to do the product rule over and over and over, right? But keep in mind what we know about this shortcut. So I'm going to call that this g of x. I'm just going to call this y for right now, okay? So if we have this y, and let's say supposedly, right, if this were really nice for us, I could put in an ln here. because so far this is what we had learned from our previous example, right? Our previous example had an ln. This one doesn't, which just means that let's say we take the ln of both sides. So what I mean by that, excuse me, is if I were to write in my own ln, there isn't one there, but I'm going to write one in. As long as I do it to both sides, it's okay. In which case, I can go ahead and derive as I normally would here. So pause the video and see what you can come up with here, just on that one side. Ignore the other side. So here, let's take the derivative, d over dx, right? So in our case, those multiplication symbols turn into addition signs. Right? So they all get derived. And so we have ln, not ln, I'm so sorry, 1 over x squared plus 1. Chain rule it, we now get 2x. Plus 1 over 2x plus 5. And chain rule, we're just left with a 2. So all together, we have 2x over x squared plus 1 plus 3x squared over x cubed minus 3 plus 2 over 2x plus 5. So this is the derivative of this one side. Now we still have, though, the derivative, right? If you take the derivative of this side, and we want to keep everything nice and even, that just means that we also have to take the derivative of the other side, meaning that we have the derivative of ln of y. Now, keep in mind, the derivative of this is 1 over y. That is dy, or d over dx, right? But notice that we now need to figure out, okay, we need to get the derivative of y alone and on one side, which means, because this whole thing is the derivative of x, right? And I know we're talking about y here, but bear with me. I know it's not going to be d over dy, right? So in this case, let's go ahead and multiply y to the other side times y, or times y over here. And this whole thing is being multiplied by y. And that way it allows us to cancel it with one side. And so this whole thing is d over dx. That is the derivative of y, or in our case, the derivative of g of x, meaning that we have y times this whole thing. And I'm actually not going to write that whole thing. I'm just going to copy and paste. So the last thing to do is that this y, right, because we need everything in terms of x, x, x. But we already know what y is equal to. Y is equal to this whole thing here. So that just means we now need to replace this y with its counterpart. X squared plus 1, x cubed minus 3, 2x plus 5, and then times, paste one more time, this whole thing. This is the derivative of g of x. So you'll notice that we've just replaced y. So to recap, right, I'm going to do a step-by-step process. To recap, step number 1 is to take the ln of both sides. Step number 2 is to derive both sides using properties of ln. Step number 3, multiply y to the other side. And step number 4, replace y with original function. Now, no, you don't need to do this every single time as long as you understand this following rule. Okay, so this is kind of that step-by-step process on how we get to it. But otherwise, the whole thing of g of x, the derivative of g of x, is equal to g of x. That is to say, this was your y times the derivative of the inside function using ln properties. So let's have you guys try it one more time with example 3. So you'll notice that no, there's no ln in sight. So we have to take the ln of both sides. And I'm just going to call this y. I'll just label that as y. So you take the ln of both sides. And now let's go ahead and derive. This one becomes 1 over y. This one we can break up into its properties. So if I'm doing it really quickly, well, actually, if I were to kind of do it slowly. Right, there we go. Now we can take the derivative, 1 over x cubed minus 3, chain rule it, plus 1 over 4x plus 3, chain rule it, plus 1 over 5x squared minus 2x, chain rule it, 10x squared, 10x minus 2. Now let's go ahead and multiply both sides by y. So we have y over here, and I'm going to clean it up. We have d over dx over here. So we have 3x squared over x cubed minus 3 plus 4 over 4x plus 3. And I'm going to take out a 2 from both, so this should be 2, 5x minus 2. Here, we get to take out an x, so we could do 5x minus 2 over here. So we have plus 2, 5x minus 2 over here, all over x, 5x minus 2 here. Those will cancel. Last thing to do is to grab your y. Oops. Undo that. There we go. Last thing to do is d over dx, which is equal to your initial y. We said was that initial function up here. So this thing right here. So we have x cubed minus 3, 4x plus 3, and 5x squared minus 2x times that whole thing. Let me erase that part. And move it up. There we go. And there you have it. The derivative of, or sorry, you take your y, your initial, times the derivative of the inside, given that we've broken it up with ln property.